Subscribe the channel and press the bell icon. Hi there. Today we are going to learn properties of Laplace transform. In that we have first property, that is linearity. The linearity property states that the Laplace transform of the weighted sum of two signals is equal to the weighted sum of the individual Laplace transform. Suppose we have two functions x of 1 of t and x2 of t, and their corresponding Laplace transform is this, and this one has the Laplace transform that. So the Laplace transform of the summation of them will be the weighted sum of the individual Laplace transform. Okay, suppose we have one question, u of t and e to the power minus t u of t. In our previous video, if you don't know, you can press I button and you can see the introduction of Laplace transform, where I have derived the equation from the integration. From there we can see that u of t has 1 by s Laplace transform and it has 1 by s plus 1. So the Laplace transform of the both signal will be 1 by s plus 1 by s plus 1, and we have to s plus 1 plus s divided by s plus 1. So it will be 2s plus 1 divided by s square plus s will be the Laplace transform according to this. Got it? It's very easy. Now moving towards next property. Next property is time shift property. Time shift property states that if any function having Laplace transform x of t, x of s, then the Laplace transform, if we shift the time by t time, then the corresponding e to the power minus st will come out. So this is the Laplace transform. And by taking any of the example, suppose if we have this as an example, so what u of t has Laplace transform 1 by s. Now we have what, for e to the power minus 2t u of t, we will have Laplace transform of 1 by s plus 2. Okay, now we are seeing there that the time shift we have is minus 3 over here and minus 3 over here, both having same time shift. So now what we can do for the Laplace transform, you can write here Laplace transform. So the Laplace transform of e to the power minus 2 t minus 3 u of t minus 3, what we will have, we will have e to the power minus s, and how much is the time, is 3. We can write over multiplied by here by 3 and divided by s plus 2. What we will have, we will have e to the power minus 3s divided by s plus 2. This will be the answer. So moving towards the next slide, time scaling. For time scaling, if x of t in t is multiplied by a, then while taking the Laplace transform we will have 1 by a, okay, mod of a, and s is replaced by s by a. So for we know that what, for u of t we have Laplace transform how much, 1 by s. Okay, now what we have to do for at, what we have to do, u of a t, the Laplace transform will be 1 by a for sure, and replacing s by a, that means what will have 1 by a multiplied by 1 divided by s divided by a. This a and this a will cancel out, and what we are having, 1 by s. So your doubt might be clear with this time scaling. Now moving towards next, multiplication by a power of t. Suppose a function t of 2 to the power n x of t is given, then what will be the Laplace transform of that function? Okay, what will be the Laplace transform? It will be minus 1 to the power n d n divided by dsn x of s. Okay, so taking one of the example is r of t. R of t is what? T of u of t. Okay, and we know that for u of t the Laplace transform is what? 1 by s. And now what we have to do by applying this property? What we have to do? We have to differentiate it by one time. Okay, that means what will be the function? What will be the t u of t Laplace transform? It will be very much simple, minus 1 to the power 1, since because t to the power n, where n is equals to 1 over here. Okay, so it will be minus 1 to the power 1, and we have to differentiate d by ds how much? One time. That means we have to differentiate 1 by s. So what will be the output of this? Minus will be outside, and what will be the s square? Okay, and s will be the outside, minus multiplied by 0, and then minus 1 multiplied by 1. So here this whole term will get to the 0, and this will be minus, and minus will be multiplied, and what will be the output? Output will be plus 1. So it will be 1 divided by s square. Okay, have you understood? So moving towards our next property, time domain differentiation bilateral. Suppose if we having a function and we have to differentiate x of t by means any order, by nth order, then the how much the order, that will be the output. Suppose if we are differentiating d by dt and one time, okay, suppose anything u of t, that means we have to what? S will be 1 outside, and for u of t the Laplace transform will be 1 by s, so it will get cancel out. Okay, suppose simple we have a question delta of t, so try by yourself. I had given a hint over here. Okay, pause the video and try to solve it by your own. Okay, similarly for integration, if we have integration that is from 0 to t x, and we are differentiating it, then the output will be 1 by s of x of s. A similar function with you can establish the similarity between differentiation and integration. For integration it will be 1 by s, and for differentiation it will be s. Okay, have you understood? So moving towards next property. For next property, if we having convolution, if you want to find out the convolution of any function, then what? The convolution integral. Suppose if y of t is equals to x of t convolution of h of t, and that this very function we are very well known of, this is convolution, and the Laplace transform is the analogous to the Fourier transform. So y of s will be the product of x of s and h of s, but because the Laplace transform and its inverse to be discussed moment are not symmetric, the dual of this is not true. That means if we are trying to find out means if you want to reverse this function with this function, that will be not true. Okay, this is the one reason the Fourier transform is more popular for the application involving communication system and modeling. Okay, the ROC is at least overlap of ROC for each signal. Again, it can be larger than the ROC of for either signal. Simple. We have to suppose find out the x of t. We have a function, suppose we have a function x of t, and that is u of t minus 1. Then the x of s will be what? 1 minus e to the power minus s divided by s. How I find out? Simple. It is for u of t, it will be how much? 1 by s minus, and we are seeing here what? Time shift. Therefore we have e to the power minus s and divided by s. If we take the LCM, we have the same output as mentioned over here. Similarly, for yt equals to x of t convolution of x of t, that means x square s. Simply what we have to do, we have to multiply this ever function 2 times. Okay, and that will be the square. Okay, got it. And similarly for the this one is the inverse of the Laplace transform. Okay, this we will see on later on this course when we will discussing about inverse of Laplace transform. Okay, so moving towards next, initial and final value theorem. So application of initial value and final value theorem, how can we can do? So if we know that x of s is equals to the numerator and denominator. Okay, and for applying the initial value theorem, we can see that x of 0 is equals to limit s tends to infinity s x of s. For example, we can take the example x of s if we have 1 by s plus 1. Okay, for this what we can do, limit, we are going to find out initial value. So what we can do, s tends to infinity s multiplied by 1 divided by s plus 1. We can see it's in the form of infinity by infinity, so we will differentiate numerator and denominator one time. So we will have output or answer of this function will be 1 divided by 1. So 1 is the answer. Similarly for this function also we can try s multiplied by 1 divided by s plus 1 ka its square, and its limit s tends to infinity. Okay, so what we can do over here, we can it's infinity by infinity. By differentiating one time, we will have 1 over on numerator, and there will be degree 1 in denominator. Again, if we will differentiate, then on numerator there will be a constant, and in denominator we have a constant value, but the answer will be, if since it is 0 on the numerator side, so we will take it 0. So coming up on the final value, it's x infinity equals to limit s tends to 0 and s x of s is equals to 0 for the, if the x of s tends to 0 is less than infinity, no poles at s equals to 0. So similarly, if we want to find out this function, this what we will have, limit s tends to infinity, and we have s divided by s plus 1, and after putting the value equals to 0, we can see in denominator we have a value of, it's in the form of 0 divided by 1. So it is not in any kind of, means we can't give him the limit form, so the direction the answer will be directly equals to 0. Similarly, coming up on this, what we have, s divided by 1 by s ka square. So after putting the value of s tends to limit s tends to 0, we will have an answer of 0. So these are the properties of the Laplace transform. Okay, so we have a summary. What for linearity, simple, whatever constant is multiplied to the function, for the Laplace transform same constant will be multiplied for both the function. Okay, for time shift we have to take out the constant, what is the how much the shifting is has been done by e to the power minus c of s. Similarly with time scaling and multiplication with power of 10, then we have to do differentiation, multiplication with an exponential, then exponential. For exponential we have to simply, what we have to do, we have to say s, we have to put s equals to how much, s minus a, as you can see over here. Similarly multiplication with sin omega t, cos omega t, and these are the set of values. You can take the screenshot of this all and you can apply over the Laplace transform application. These are very good short tricks to solve any kind of the problem of Laplace transform, and it's very easy and it is widely used. Okay, hope you have understood this video, and if you have liked this video, please subscribe to the channel and give a like to us. Thank you.